Welcome to this short recorded video that will go over the improving the secant algorithm activity for the Part A lecture notebook on Module 4 of Computational Applications. So in this particular activity, the same notes as the first two activities really apply here in terms of creating additional cells and really playing around with it. At the end of the day, I want you to create a secant improved class that is improved from what is implemented in secant in the sense that it checks for and avoids any potential errors. Basically no division by zero, that may occur both before any computation takes place and also during runtime. Also allow the plot secant method in the class to set the tolerance parameter. So I'm really just going to show you what you need to edit in this code. So you take this secant class, this object, copy it, paste it below, change the name to secant improved. Okay? The way it's improved is that it checks for and avoids any potential errors, no division by zero, that may occur before any computation takes place. So when we compute secant and we look right here at the compute secant method and we create these lists, the thing we need to check is that the difference between these two is not zero. So a good way to check that, right, is right away before any computation takes place as well. You could do it right here in the loop. So here you could just check if self.fs of -2, just look at what you're dividing. In fact, here, I'll just go ahead and do this. Let's check to make sure that it's just not close to zero. So if np.absolute value of that difference, if the absolute value of that difference, let's say, is less than, let's say, 1e to the negative 10 to the negative 15th, right? That's a pretty small number. You might even go smaller than that. Then you might just return. And you could say, so this could be just like with our bisection if you look at how we created at the checks here. So I'm just going to go ahead where we have this. We could raise a value error. Let's raise a value error. That's a good idea. Let's raise a value error. So here, where's our secant? Secant improved. I think raising a value error is even better. So instead of returning, we'll just raise. You could just raise a value error where you're just in a approximate division by zero error. That's a good thing to do. So now we're checking that we're getting close to where these values are so close to each other. They differ in the 10th decimal spot, basically, that we could be getting close to dividing by zero. We maybe don't want to trust these values. And so we should perhaps stop, raise that value error. So that's one way to do this. And then we also want to plot the secant method, we want to allow the plot secant method in the class to set the tolerance parameter. So here with this tolerance parameter, right, that's being used, if you look in the plot secant, it doesn't show up. So you might just go ahead and add that tolerance f equals none, and if you have it, you just want to set it. So if you pass none, nothing changes in setting the secant parameters, but maybe you want to change it. And so then that's it. So with any new x naught, x1, in or tall f values. That's a good way to update that. That's it. That's pretty direct edits to this class, not much to do. And then from there, I want you to test your code like you've done before. So again, you could kind of do some copy and pasting, testings with Lambda functions, show it with the interact with the widgets. Only asking there, if you want to do it without widgets as well, that's okay, but also use the widgets for the plotting of each instantiation of the class. So just show a few plots, show some instances of it. But this is it. As far as the changes to the code, that's pretty much what you have to do. Thanks for listening.